All right, let's talk about a real titan of technology, a name that's pretty much everywhere you look, from massive company servers all the way to the phone in your pocket. I'm talking about Java. It's a programming language that has been shaping tech for decades. And believe me, its story is packed with some really surprising twists. So, to really get to the heart of Java, you have to start with a pretty basic question. Back in the early 90s, we already had a bunch of programming languages, things like C and C++. So why in the world do we need another one? Well, the answer is probably not what you think, and it has absolutely nothing to do with the internet. Yeah, you heard that right. You think a language this dominant was built for the web, but that's the big twist. It wasn't. Java's original mission was, well, it was for toasters and microwave ovens and remote controls. The goal wasn't to connect the world, it was to make all those little gadgets in our homes a whole lot smarter. Now, to understand why this was such a game changer, we kind of have to rewind and look at the world before Java. And the core problem, the real headache, it all boiled down to one thing, just sheer complexity. Just think about it for a second. In the early 90s, every single electronic device had its own little brain, right? Its own CPU. So the chip in your microwave was different from the one in your remote, which was different from the one in your TV. And trying to write software for all of them, it was a total nightmare. You couldn't just write one program and expect it to work everywhere. This whole situation created a massive bottleneck for progress. See, a language like C++ needs a special translator, we call it a compiler, for every single type of CPU it runs on. So, if you were a developer, you needed a compiler for the TV chip, another one for the microwave chip, and on and on. Building and managing all those different compilers was incredibly expensive and painfully slow. It was a huge barrier, and for the booming world of consumer electronics, something just had to give. And this, right here, is where the absolute genius of Java enters the picture. The team over at Sun Microsystems cooked up a truly revolutionary solution to this whole portability mess. The secret sauce was this thing called bytecode. It's the magic trick. Instead of compiling your code for a specific physical computer chip, like an Intel chip or whatever, Java programmers compile their code into this universal middleman format. This bytecode isn't meant for a real machine you can touch. It's designed for a virtual one. And the process itself is just brilliant in its simplicity. So a programmer writes their code one time. That's it, just once. That code then gets compiled into that universal bytecode we were just talking about. Then any device, and I mean any device, that has a little piece of software called the Java Virtual Machine, or JVM, can understand and run that exact same bytecode. The JVM is basically a universal translator, making the code work on everything from your toaster to a massive supercomputer. This incredible breakthrough led to what is easily one of the most famous slogans in the history of software: write once, run anywhere. That single promise, that one idea, it solved the enormous headache of trying to program for a world full of different, incompatible devices. This was the key to all of Java's power. But okay, here's where the story takes another huge turn. This language, the one designed for smart appliances, was, almost by accident, perfectly built for the biggest technological tidal wave of the time, the explosion of the World Wide Web. I mean, think about it. The early internet was the ultimate run anywhere challenge, right? You had millions of different computers with all kinds of operating systems and CPUs all trying to talk to each other. So a language that was specifically built to be platform independent wasn't just useful, it was exactly what the web needed to go from a niche thing to a global phenomenon. Java basically gave the early web superpowers. The most famous of these were applets. These were tiny, interactive programs that could download and run right there inside your web browser. But what was really crucial is that they were secure. Because they ran inside that JVM sandbox, they were walled off and couldn't mess with or harm your actual computer. And of course, they were portable. The very same applet could run on a Mac, a Windows PC, or anything else connected to the internet. And it wasn't just about portability. Java was built from the ground up with this philosophy of being super reliable. These buzzwords really capture it. For example, being object-oriented was a clever way to organize really complex software into neat, reusable pieces, kind of like digital Legos. And being robust meant it had all these built-in safety nets to keep programs from crashing. This was never just a language for flashy web animations. It was engineered to be tough enough for the really serious, mission-critical stuff.
But Java's story didn't peak with the early web, not even close. If you had to define the language, you'd say it's defined by a culture of nonstop innovation and evolution.
A perfect example of this constant adaptation is the jump from applets to servlets. You see, as the web got more and more powerful, the real action started to move away from the user's browser, what we call the client side, and onto powerful web servers. And Java adapted beautifully. It became a powerhouse on the server side with servlets, which are the engine behind so many of the huge web applications we all use every single day.
And this evolution has only gotten faster. We saw huge leaps, like the collections framework back in '98, which made handling data way easier. Then, fast forward to 2014, and you get modern features like Lambda expressions, which made the code itself much cleaner and more powerful. And today, the pace is just relentless. Since 2018, Java has been putting out a major new release every 6 months. It's built to keep up. So, after all these years and all these changes, what is Java's identity now? What's its enduring legacy? You know, there's this great quote that I think just perfectly captures the soul of Java. Java is not a language with training wheels. It is a language for professional programmers. And that's it, right there. It was always meant to be a serious, heavy-duty tool. It was designed from day one to solve really complex problems with a focus on being reliable and secure. It's the language you use to build the industrial-strength software that our world runs on. And that really brings us right up to today, and to the future. That culture of innovation is stronger now than it's ever been. Java keeps adapting to the Internet of Things, to cloud computing, to AI, and it makes you wonder, with that kind of momentum, what new, unforeseen challenges is Java perfectly positioned to solve next? What's the next big thing it was accidentally built for?